Howdy, Sam Flippin, we're looking at the biotic and abiotic factors of ecosystems. So science I'm saying we're going to look at ecosystems can be diverse and can be defined by their biotic and abiotic components and the interactions between elements of these components, distinguish between biotic and abiotic components, compare characteristics of at least two ecosystems. So we need to remember what our definition of an ecosystem is. An ecosystem is a community of populations interacting with the physical environment. Living components within an ecosystem are the biotic factors, and non-living components are called abiotic factors. So let's have a look at this picture down here. I want you to list some biotic factors, and now I want you to list some abiotic factors. So the biotic factors we can classify as producers, consumers, and decomposers. Producers are autotrophs. That means auto means by yourself, and troph means eating, so they kind of eat themselves. They convert inorganic materials into organic materials using sunlight through photosynthesis or chemical energy. We're going to focus on plants. Plants do this using sunlight through the process called photosynthesis rather than chemosynthesis, which is this one over here. So in most terrestrial ecosystem, it's plants which are the producers. Producers are very important because they provide food to the at least first level of consumers, and then other levels of consumers eat those first levels of consumers. So the plants are very important because they're the basis of the food chain. In aquatic ecosystems, it might be algae. Sometimes it's plants too, but it could be algae. So here's some algae down here. These are single cellular algae, but algae can also grow in clumps together. Like here we have seagrass, and now here we have a large tree. We're going to talk about food chains briefly. So in the food chain you have a producer, and then you have something that eats the producer called a consumer, and the first level is called a primary consumer. Then you have something that eats that primary consumer, that's called a secondary consumer, and so on and so on. Decomposers work at every level of the food chain because everything dies and gets broken down by decomposers. So what's a consumer? Consumer is heterotrophic. Hetero means other, so other eating, so eat other things. So they obtain their materials and energy by eating other living things. So down here we have someone eating a hot dog, and that's because they're a consumer. Humans, animals are consumers by their nature. So we need to get our compounds both to make up our bodies, so things like proteins and carbohydrates and fats and oils, but also our energy. So carbohydrates we get a lot of energy from, as well as fats and oils. So we get that from the food that we eat. So we can't make our own food. We're not plants. We can't just stand out in the sun and photosynthesize and make sugar. We can't do that. Decomposers are very important because they break down dead or decaying organisms into smaller components that may be reused in the ecosystem. Energy isn't recycled, but nutrients are. So things like carbohydrates can be broken down into carbon dioxide and water, and that carbon dioxide and water can be used to make new carbohydrates. Down here we have a fungus. This fungus here is acting as a decomposer. So the tree that it's on isn't very healthy. The fungus dissolves away the tissues of the tree and uses that to grow. Fungi are important decomposers, but the most important decomposers are bacteria. They're the most common decomposers in nature. So I mentioned food chains before. Here's a question. What's wrong with this food chain down here? So what's wrong with this food chain is the decomposers are only acting on the apex predator, whereas in reality they act at every single level of the food chain. In a food chain, you get producers producing food for consumers. Those consumers eat producers or other consumers. And this goes up several levels. So we have primary, secondary, tertiary, quaternary, and so on. Decomposers are acting at every single level. Now, food chains aren't really a good representation of what's happening in an ecosystem because there's often much more complex interrelationships between predator and prey. If we have here, we can see the one path for the energy and nutrients. In this one, we can see there's multiple paths. So the grass might be eaten by the grasshopper or it might be eaten by the rabbit. In either case, they're both primary consumers. The grasshopper might be eaten by the mouse or it might be eaten by the bird. So both of those are secondary consumers. So we don't see that in the food chain, but we do see it in the food web. So now we're going to talk about the abiotic factors. The abiotic factors are non-living components of an ecosystem that affect living components. A good example is sunlight. So here we have sunlight going through trees. Sunlight's very important because it's providing the energy for producers to do photosynthesis. Water is also very important in an ecosystem. So water is required by producers for photosynthesis. So for photosynthesis you need water and carbon dioxide. But all living things need water to survive, so water is a very important part of an ecosystem. Other abiotic factors are gases like oxygen and carbon dioxide, and these are required by living things. We require oxygen to breathe, to break down sugar. We break down that sugar into carbon dioxide and water, and the carbon dioxide is used by plants to make sugar. So it's a big cycle of gases like oxygen and carbon dioxide, but water vapor is a gas as well, and that's part of this cycle too. Temperature is very important. So if you have really high temperatures, like over here in the desert during the day at least, that's going to have big impacts on the community of organisms that you have present. If you have really low temperatures, like down here in Antarctica, again, there's going to be a different mix of organisms that can survive in that community due to the temperature difference. With soil, soil is made of broken down pieces of rock, but soil can also contain nutrients, and both of these are inorganic, they're not living, and they're very important, particularly on land. On land, you need to have several components of your soil in order for the soil to be fertile enough to support plants growing in. So over here we have a diagram. What's wrong with this diagram? So I can spot a few things. One, it's got hydrogen floating around individually. This doesn't really happen. Hydrogen is a very low component in the atmosphere, and it also float up into space too. Carbon is usually fixed to oxygen and carbon dioxide. You don't have particulate carbon floating around, and if you do, that's probably not a good thing. You've got a fire somewhere. Some of the elements down here we're going to look at in terms of the biogeochemical cycles later on, nitrogen and phosphorus in particular. All of these substances down here, for the metals, they're usually in the form of their ion, which makes them soluble in water rather than the solid form. And things like nitrogen, they're in compounds rather than nitrogen gas, which is how it's found in the atmosphere. So we're going to look at that a bit later on. Key point is, in soil you need to have several nutrients so that plants can grow successfully. If we look at a desert, for example, there's low nutrient soils, and that's why plants don't grow particularly well. So let's compare a couple of ecosystems. So as I said, the abiotic factors determine the community composition. Ecosystems with poor soils, low sunlight, low temperatures, and low rainfall, they're not going to produce very many producers, and therefore there's not going to be too many consumers. So a good example of this is Antarctica. So in Antarctica, you have a lot of surface ice, which isn't soil, so it makes it very difficult for plants to grow. During the year, the sun disappears below the horizon for a long period of time, so that would affect producers' ability to grow. It's very cold, and there's not much rainfall down in Antarctica. So that means that not many producers are present, and therefore there's not many consumers either. Where you do get animal life, it's at the edges where they can go into the ocean and feed there. So let's compare a couple of ecosystems. Let's talk about a rainforest. So a tropical rainforest has a large amount of rainfall, lots of sunlight, warm temperatures all year round, high quality topsoil but low quality deeper soils. The reason for this is you get a lot of vegetation falling onto the top of the soil, and that breaks down and that produces high quality topsoil. But deeper down, where you have lots of trees in a rainforest, those trees have already tapped out the nutrients that are present deep down in the soil. So the soil quality lower down isn't as good. What this means is if you cut down a rainforest, you don't necessarily grow lush vegetation afterwards because the soil quality isn't particularly good. This combination of abiotic factors leads to large trees growing. You get ferns and smaller shrubs taking up some space down at the bottom levels of the rainforest. What this means is a lot of the light is sucked up by these plants, so only 6% of the light that shines on the rainforest makes its way down to the ground, depending on the type of rainforest, of course. Since there's a large variety of producers, we get a large variety of consumers as well. So insects, birds, frogs, monkeys, jaguars, snakes. Depending on where you're living in the world, you get a wide variety of consumers being present in your ecosystem. You get fungi and other decomposing species also being very common. So we talked about tree fungi before that are breaking down the trees that have fallen over. Because of the weird combination of high-quality topsoil, low-quality deeper soils, we get things like carnivorous plants being present in rainforests too. So this is a carnivorous plant that takes in animals. That's because there's low nitrogen in the soil, or low available nitrogen in the soil, in the form of things like nitrates. So they kill animals instead and break the animals down to get proteins and then break them down to nitrates that they can then use. So let's compare our rainforest to a desert. So in a desert you have low rainfall, large amounts of sunlight, high day temperatures, and low-quality soil. So because of this, you don't get too many producers. Even though there's large amounts of sunlight, which producers could take advantage of, the low-quality soil and high temperatures, plants don't do particularly well there. Some plants have adapted to survive in these conditions. So here we have some spinifex type grass, so spinifex grass here, and cacti. So these plants have adaptations which allow them to survive a bit better. The cacti, for example, they're particularly good at retaining water for long periods of time, so that when it does rain, they can suck up as much water as possible and then use that water for a long period of time. Since there's few producers in deserts, you also get very few consumers, and the consumers that are present are also very highly specialized to survive in the desert ecosystem. So this is a spinifex hopping mouse. One adaptation it's developed is that it doesn't have to drink water. It gets all the water from the food that it eats, so it doesn't need to drink surface water in order to survive. It has very highly specialized kidneys that extract as much water from its body systems as possible so that it doesn't urinate very often. When it does, it's highly concentrated, so it doesn't waste too much water. So now in Flippin Science, we looked at abiotic and biotic factors that have an impact on ecosystems, and we also compared a couple of ecosystems. That's it for Flippin Science today. See ya!